Hello everybody, welcome back to this is the fourth section of Chapter 7 on hypothesis testing, and we will be talking about hypothesis testing for population proportions in this video. So we've already discussed how proportions are really based on a binomial probability distribution, but we know that when the conditions are right, we can approximate it with a normal distribution, and that's what we're going to use to do this. So let's just go through the general guidelines. You'll see it's very similar to what we've been doing in the last couple sections with hypothesis testing for the means. It's just a few little tweaks that we have to worry about. So as usual, we're going to start by stating the null hypothesis. So let's say you're given a claim. The first thing you want to do is state the null hypothesis and alternative hypothesis, and identify which one is the claim. And of course, remember the null hypothesis is the one that has equality, some sort of equality in it. Then you verify the sample is random, and then you also have to check that these two values, if n is the sample size and p is the proportion stated in your claim, and q is 1 minus p, then you need to check that np and nq are both greater than or equal to 5. Okay, we need this so that we can use the normal distribution. Okay, if either of these are false, we can't go ahead. We can't use this. Then we have to we're given the level of significance, alpha, and then from there we determine the critical value or values from the standard normal distribution. Again, you ask yourself, are you using a left tail test or right tail test or two tail test? And again, that depends on what the alternative hypothesis says. Okay. So then the thing there is you want to use your standard normal distribution, so you're either going to memorize some of these values or you can just look these up on your calculator or on a standard normal table. Then from those you determine the rejection region or regions, and then you compute the standard test statistic. And remember, p hat represents your sample proportion. P is your theoretical proportion that you're assuming in your null hypothesis. Okay, and it's that P and Q that you want to use down here. So that this P and this Q, these are not from your sample. They're from what you assumed in your null hypothesis. Okay, so it's P hat minus P divided by the square root of PQ all over n. One thing you want to make sure is that this whole fraction is under the square root. Okay, so I would say compute that first, then take the square root of that. Then you reject or don't reject the null hypothesis, and then you interpret your decision according to the claim or in the context of the claim. All right. So let's look at we'll look at 3 examples here. In this first example, you're claiming that population proportion is strictly less than 12% or 0.12, and you want to test that at a level of significance of 0.01 or 1%. And in the statistical info, you took a sample of size 60 and got that p hat is 0.10, so that's your sample proportion. Okay, so we'll write down our hypothesis, our hypotheses. And because our claim has strict inequality in it, that has to be the alternative hypothesis. Which means that our null hypothesis, the complement of that p is greater than or equal to 0.12. Okay. All right, so that allows for the fact that we're letting p, we're assuming p is equal to 0.12, and q would be 1 minus that, which would be 0.88. And you can check that 60 times 0.12 is greater than or equal to 5, and 60 times 0.88 is greater than or equal to 5. So we're good to go. All right, so now let's see, our level of significance is 0.01. Because we're assuming p is greater than or equal to something, our extreme values or unlikely values for p hat would be less than 0.12. So we're talking about the left tail test. And this tail right here would be 0.01. And you can either memorize this or you can just do the inverse norm of 0.01 on your calculator, and you'll find that this is negative 2.326. Okay. All right. Then we go ahead and use our test statistic. Our formula for the test statistic, that's p hat minus p over the square root of pq divided by n. So this is p hat is 0.10. We're assuming p to be 0.12 divided by the square root of 0.12, 0.88 all over the n, which is 60. Okay. We compute and we find that this is negative 0.476. And that is going to be over here. Okay. So it's not in the rejection region. Right. So we don't reject H0. And because we're not rejecting H0, we can't support this claim. Okay, so we say there's not enough evidence to support the claim. Okay. Let's look at this next example. The claim says that p is greater than or equal to 0.48. Level of significance is 0.05. And so let's go ahead and check. We'll write down our hypothesis. Now, this, because it has equality in here, this is the null hypothesis. Okay. And that's our claim. And then our alternative hypothesis again says that p is less than something, it's less than 0.48. Okay, so now we do this and let's check that we're assuming basically p is 0.48. Q would be 1 minus that, which is 0.52, and n is 90. You can easily check that 90 times 0.48 is greater than 5, and 90 times 0.52 is also greater than or equal to 5. So we're good to go. Once again, because the unlikely values of p hat would be less than some number, we're using a left tail test. And our level of significance now is 0.05. All right. So we use inverse norm of 0.05, or you can just memorize this. This is going to be negative 1.645. So that's our critical value, and we see our rejection region. Now we compute the standardized test statistic. So this is 0.40. P is still, take P to be 0.48. Divided by the square root of 0.48, 0.52 over 90. Okay. And this turns out to be negative 1.52. Okay. we're running out of paper here, but that's all we need. We can see it's still, this is just outside of the rejection region. It's close, but it's not. But there's no cigar. So once again, we don't reject H0. And there's not enough evidence. To what are we going to do to reject the claim now, right? H0 is the claim, so there's not enough evidence to reject the claim. All right. So now I get you. Okay, we'll jump to a new video. Go ahead and try the last problem on your own, and I'll see you in the next video.